This video will demonstrate how slab reinforcement is defined in concrete bending and will show the difference between the optimized design approach and the specified design approach. Let's get started. In this example, we have an L-shaped slab that is supported by beams running in the y direction along 3 column lines. Therefore, the slab is primarily acting one way, spanning in the x direction. The slab is loaded with both a uniform load and a single point load. Looking at the analysis results, we see that bending occurs mainly in the x direction, with positive moment towards the center of the larger span and negative moment occurring in the slab over the beam support. When this model was built, 2 separate boundaries were used to create the L-shaped concrete slab. Looking at the slab section under the Find tool, we can see that the slab with the smaller area is named S1 and the slab with the larger area is named S2. With multiple slabs defined, the reinforcement details and the slab thickness can vary in the model. Note that the concrete strength is defined under the project settings and is the same for the entire model, so it cannot vary between slabs. For slab S1, the thickness was set at 7 inches and we have chosen a single matte bar configuration with the top bars being in the y direction and the bottom clear cover was set at 2.5 inches. Concrete bending supports 2 different design approaches, the optimized approach and the specify approach. The optimized approach lets the program search for the best reinforcement pattern, while the specify approach lets you input a specific reinforcement pattern for the program to check. For this slab, we will use the optimized approach. Clicking on Edit Patterns, we see that concrete bending will choose from 3 different rebar patterns, number 4 bars, number 5 bars, and number 6 bars, all at 12 inches on center. Now, based on the finite element analysis results, the program will choose the optimal rebar pattern from these 3 for both the x direction bars and the y direction bars. Had we selected a double matte bar configuration, the program would optimize both the top bars and the bottom bars in the x and y directions. For slab S2, all the parameters are the same as slab S1, except that we have selected the specified design approach instead of the optimized design approach. We have specified number 5 bars at 12 inches on center in the x direction and number 4 bars at 12 inches on center in the y direction. Now we should check to make sure that the correct steel strength is being used in the model. To do this, we will go to Design Results and click on the Modify tab in the Project Manager. Here we can set the steel yield strength for the slabs in the model. Also, this is where we can choose which design code we want to use. Furthermore, in the minimum steel section, we can specify how we want the program to address the minimum steel ratio and the minimum steel placement. Looking over in the project status, we see that the analysis and the design is complete, but there is a warning that at least one of our Unity checks has failed. For the plate checks, we are failing in slab flexure, slab shear, and we have plate design errors. Clicking on Design Filter in the Project Manager, we can go to the Slab Details section and switch from Shear Unity to Steel Suggested and look at the steel in the X direction. In Slab S1, where the optimized design approach was used, concrete bending suggests which rebar pattern should be used for each plate element of the 3 rebar options that we gave the slab. In Slab S2, where the specified design approach was used, concrete bending checks to see if the 1 rebar pattern that we set in the x direction is adequate. In both slabs, the gray color elements indicate that there is nothing available for design. If we turn on the flyby information, we can see that the max unity is greater than 1 for MX flexure, indicating that the reinforcing patterns we gave the program for both the specify and the optimized approaches are not adequate. Going back to the model and clicking on slab S1, we can add another pattern. We will use number 7 bars at 12 inches on center. Then clicking on slab S2, we can increase the bar size in the x direction from number 5 to number 6 bars, keeping it at 12 inches on center. Now switching back to the design view, we can see that there are no regions where, quote, nothing is available, and under the project status, we see that slab flexure steel now passes, and we have no plate design errors, indicating that the design passes for flexure. Thank you for watching and have a great day.